Hello everyone. Today in this session we start with a new type of function, rather new name of the function as greatest integer function. And fractional part is something which comes in the way while understanding, learning greatest integer function. Before I introduce you greatest integer function, I'm just thinking that we have been using this word function in last many sessions. And have we really understood meaning of function? Function means, if you open dictionary, it means work. Like AC works. It gives you that cool room. Fan works. So fan and AC both are giving you that cool air. So they have their certain jobs to do. Can fan replace AC or AC replace fan? No. Means AC has its own job to do and fan has its own job to do. And both are doing its job. That doing job is nothing but function. We say AC functions well. Fan is functioning. Word function we use for doing job. So understand this. Every function in mathematics has its own job to do. So greatest integer function also has a particular job to do. A greatest integer function is the one which extracts the greatest integer involved in x. Definition looks like any definition, a long statement. But we should be able to understand it on number line. That is the better way of understanding. And before we do that, let us take the notation. Notation is we write in square bracket x. That is the notation for greatest integer of x. Now let us take example so that picture is more clearer to us. I take number as 9.3 and I am asked to find greatest integer of 9.3. So what I do? I mark on the number line 9.3 and I try to mark integers before it. I mark 9, 8, 7. I can continue, but my aim is to get the greatest integer. So what would be the greatest integer? It would be 9. Greatest integer contained in 9.3 would be 9. So greatest integer of 9.3, my answer is 9. And out of 7, 8, 9, 9 is the closest to 9.3 and it is on the left of 9.3. So basically, whenever you have to find greatest integer, you mark that number on the number line and move to its left if number is a non-integer number, because 9.3 is a non-integer number. This is what, at least from this example, I have learned. Fine. Now let us take some example where I am taking negative number, minus 7.5. Its greatest integer is to be obtained. Just now I said that you mark the number on the number line and move to its left if number is non-integer number. And the very first integer what you meet, that would be the greatest integer. This is the idea. So I do exactly same. I mark minus 7.5 and the numbers, the integers before minus 7.5. Minus 8 is the closest. So when I move to left, the very first integer I meet is minus 8. So greatest integer of minus 7.5 is minus 8. In both the examples, what I have learned, that greatest integer of x would lie on the left of x. So I mark x. On the left, I mark greatest integer of x. The moment I see this picture, certain thing comes to my mind, that I kept saying that x is non-integer. So obviously there should be a case when x is integer and the corresponding things we will have to say about greatest integer of x. One thing I have understood, that greatest integer of x is an integer. One. Also, greatest integer of x, since it lies on the left of x, it is less than x. And I write there, greatest integer of x is less or equal to x. The moment I am writing less or equal to, the very first thing what comes to your mind is, when does equality occur? We have to find answer for this. I realize that whenever x is an integer itself, because you are in search of integer, right? So if x is an integer itself, then greatest integer of x and x, they will match. There is no need to move on its left. I hope you followed what I am saying. So equality occurs whenever x is an integer. Is that okay? Fine. We move to next further. And I realize that since x is on the right side of greatest integer of x, so to get x, something will have to be added to greatest integer of x. The quantity what I add, that I have written in curly bracket x. And curly bracket x, that is called the fractional part of x. Now, though I have not written there, But how many of you can understand that fractional part of x, first of all, has to be a non-negative quantity? Because you want something to be added, not subtracted. Something needs to be added to greatest integer of x, because you have to move towards x. This is one. And secondly, how much more you can add? I mean, what could be the largest quantity what you can add? One thing I understand, that it cannot go beyond 1. In fact, it cannot be equal to 1 also. Because if x is an integer, say 8, then answer is 8 only. You don't have to add anything to it, right? So if I have 8.1, then 8.1 is x and my greatest integer is 8. What I add is 0.1, right? So I have added very small quantity. Now move towards 9. If it is 8.9, number is 8.9. What is greatest integer? 8. So what would be the fractional part? It is 0.9. So that how much more you can increase so that you still are before the next integer. So the quantity what you add, it cannot go beyond 1. So one property of fractional part of x, what you can remember forever, is that it is a non-negative quantity, means greater or equal to 0 and less than 1. This is something what you have to remember about fractional part of x. Let us move further. Let us take some properties of greatest integer of x. First property what I have is that greatest integer of x is greater than x minus 1 and it is less or equal to x. Mind you, please, I have written equal to only at one end. That is the right end. Why do I say so? Because greatest integer of x can be equal to x provided x is an integer. So equality occurs at the right end, not at the left end. Next property is greatest integer of x plus n is greatest integer of x plus n. Plus n I have written outside. The condition on the n is that n should be an integer. Fine. Let us move to next. Next property is that greatest integer of x plus y is greater or equal to greatest integer of x plus greatest integer of y. It is exactly in the opposite nature of absolute value what we had learned. In absolute value of a plus b was less or equal to absolute value of a plus absolute value of b. Here it is other way. Greatest integer of x plus y is greater or equal to greatest integer of x plus greatest integer of y. Next property looks quite lengthy, but you will have to remember from problem solving point of view that greatest integer of x plus greatest integer of x plus 1 by n plus greatest integer of x plus 2 by n plus and so on up to greatest integer of x plus n minus 1 upon n. That is greatest integer of nx. This property must take your attention because look at the right hand side. Right hand side is greatest integer of nx. N is an integer, right? I have written there n, a natural number. N cannot be taken outside like how we have done in the second property. Second property, we have kept n outside. You cannot write n into greatest integer of x. My whole insistence was actually on this, that greatest integer of nx has a separate formula, and that is greatest integer of x plus greatest integer of x plus 1 by n and so on up to greatest integer of x plus n minus 1 upon n. I hope these properties are clear to you. Now again, as I said before, that most of the time I say try to connect it to the graphs so that things are more clearer to you. So I start with graph of y equal to greatest integer of x and go exactly by definition. Now definition says that I am taking only few intervals. You can continue in the letter interval, previous intervals also. I had taken say minus 3 to minus 2 as my interval. I realize that at minus 3, greatest integer would be minus 3. And for all x between minus 3 and minus 2, greatest integer is again minus 3. By definition, I am saying. So, I try to plot it. And I will get the line segment between minus 3 and minus 2 on the x-axis. Below that, I draw at the height minus 3 down. Right? Then I go to next. I take points from minus 2 to minus 1. And I'll get value for y as minus 2. I mark that. And I continue to do so. I have drawn here up to say x belonging to 2 to 3. And I have drawn the graph. The graph tells you something. What does it remind? It looks like a step. So actually greatest integer of x is also called the step function. People call it actually step function because it looks like a step. But the thing is there is another function which I'll be not taking here, but that is called least integer function. Actually, the graph of least integer function also looks like the similar step, but the shifted one. So the thing is, when we use step function word, then it could create unnecessarily some doubt whether it is greatest integer function or least integer function. So I generally avoid saying step function and I say greatest integer function. Look at the graph and I'm sure now you will never forget greatest integer function. Now in the talk I have mentioned somewhere that fractional part also. So let us quickly take the graph of fractional part also. So fractional part of x graph we are trying to draw. Go by definition again. Fractional part of x is x minus greatest integer of x. I take particular intervals. Why do I do so? Because greatest integer of x has certain value in certain interval. Like between -3 and -2, it is -3. In -2 to -1, it is -2 and so on. So if I have taken interval -2 to -1, y becomes x plus 2. So I will have to draw the graph only over the interval -2 to -1. And it would be a line slant between -2 and -1. But when I write definition in the interval -1 to 0, the definition becomes x plus 1. So that line x plus y equal to x plus 2 what I had drawn, that will not be drawn over the interval -1 to 0. But we will be drawing actually y equal to x plus 1 over the interval -1 to 0. So two slant line segments I have shown there. Continue this. In 0 to 1, we draw y equal to x. In 1 to 2, we draw y equal to x minus 1. And in 2 to 3, I draw line y equal to x minus 2. So we get some hexa kind of graph for fractional part of x. So now in this session, we have done properties of greatest integer function. We have drawn graph of greatest integer function. And also we have drawn graph for fractional part of x. I think this should be sufficient for you to revise. Please revise till I come back. Stay tuned. Thank you.